All right, we're going to talk about Cramer's rule, which is a way to solve systems of equations. Pretty nice little simple way to solve systems of equations. But before we start, we have to talk about some new ideas with matrices. And when you have a matrix, say A, B, C, D, with 4 elements, for example, then we're going to define something called a determinant. And usually we represent this with 2 parallel lines, kind of like the absolute value along the outside of the matrix. So the determinant of a matrix for a 2 by 2 matrix is really pretty simple. It is just A times D, so this times this, so you do this diagonal minus the opposite diagonal, minus B times C. So, for example, if I had 3, 2, 6, 1 as my determinant, my 2 by 2 determinant, 2 by 2 matrix, then the determinant of that matrix is going to be 3 times 1, it's this, minus this, minus 2 times 6. So it's 3 minus 12, or minus 9. So that's how you calculate a determinant, a 2 by 2 for a 2 by 2 matrix. So let's look at Cramer's rule now. We're going to use determinants in Cramer's rule, and that's why we talked about them. So if we start with this system of equations, ax plus by equals s, and cx plus dy equals t. So I have this in general form. The coefficients are by letters a, b, c, and d, and we have variables x and y, and then we have this all equals these constants s or t. So for example, I could have the system of equations. Let's write it over here. 3x plus y equals 2, and then 2x plus y equals 1. Now, of course, we could solve this with any of our other methods. We could substitute. We could solve for y, substitute it in here, and then solve this for x, and substitute that back into here to get y again. But Cramer's rule is a little more straightforward, simple approach. And what we do for that is we solve for x and y directly. So x equals and y equals. And the way we do this is we have 2 determinants, a determinant in the numerator and a determinant in the denominator. Let's start with the denominator first. So the determinant in the denominator is going to be made up of the coefficients in front of the variables. So we got a, b, c, and d. So that's that determinant. And the same for y. It's the exact same. A, c, b, and d. So it's this, 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 and this. It's the coefficients in front of the variables. Now, the numerator for x is slightly different. On this side, it's still b and d, but over here, we replace a and c with s and t. And for y, we have a and c is still the same here for y, a and c, but now we replace b and d, the y coefficients, with s and t. And we solve these determinants and we do the algebra here, and we get what the value for x and y is. So let's do that over here for our system. So with the denominators first, we'll have 3, 1, 2, 1. That's the denominator's determinant. So y, this is going to be the same. 3, 1, 2, 1. And then for the numerator of x, we have, over here we have 1, 1 for the 2 1s in front of the y's. But then we pull the 2 here and the 1 here. And then over here we have the determinant 3, 2. And then we put the 2 and the 1 here. So now it's just a matter of solving these. So x equals 2 times 1 minus 1 times 1 divided by 3 times 1 minus 1 times 2. So we're always taking these, this minus this, this minus this. Okay? And then, of course, this equals 2 minus 1 over 3 minus 2 equals 1 over 1 equals 1. Excuse me. Now, let's move this over. The y value is calculated in the same way. This is now 3 times 1 minus 2 times 2 over 3 times 1 minus 2 times 1. It's the exact same number is going to be over here. So this is 3 minus 4 over essentially 1 again equals minus 1 over 1 equals minus 1. So x equals 1, y equals minus 1. You can plug those in this system of equations and see if it works to check your answers. And that is Cramer's rule. It really is just that simple. So this is for 2 variables. If we had 3 variables, we would do the same thing, except we would have 3 different equations here. So you'd have maybe an ST and a V. And again, you would set up the X, Y, and then you'd have a Z. The denominators would all have the same matrix, except it would be a 3 by 3 matrix instead of this 2 by 2 matrix. And then in the numerators, you would replace the column vector here, the STU, for example, for the x term when you were solving for x. For y, you would replace the y term, and for z, you would replace the z term. So this means that for 3 or more variables, you're going to have to solve larger determinants. So how do we solve larger determinants? Well, the way you would solve this determinant is, what you do is you choose a row or a column. So for me, I'm going to choose this row. And then you choose a column. And you create what is called a minor. A minor matrix. Let's actually do the first minor with the first column. So you create a bunch of minor matrices, and we're going to do that by selecting this first row here. So now my minor matrix is this matrix. So I have 1, 0, 2, 1. And I want to get the determinant of that. And then I'm going to go and I'm going to continue to use this third row, but now I'm going to create another minor matrix by by eliminating the middle column. So this will be 3, 2, 0, 1. And finally, I'm going to stick again with this bottom row. Because it has a 0 in it and it has 1s, it's going to be easy for me to work with. I'm going to eliminate this value and create another minor matrix 3, 2, 2, 2 out of what's left. So that's the 3, 1, 2, 2. Okay, now I'm going to take this first one and I'm going to multiply it by 1, positive 1. The second one I'm going to multiply by negative 1, and this third one I'm going to multiply by positive 1 again. So this is just a constant that multiplies by these. And finally, I'm going to, so this is what we call, each of these is what we call a cofactor. And finally, what I'm going to do is the row I chose here, this row, when I did this first, when I found my first minor matrix, there was a number here that intersected the column in the row. I'm going to multiply this by that number. Now you can see why I chose this row, because I'll add this then to, now when I did this one, and I have 3, 2, 0, 1 as my minor, I'm going to multiply this by this element, which is going to be 0. So that's going to eliminate this whole thing. And then finally, when I do this one, and I have 3, 1, 2, 2 as the minor, I'm going to multiply this by 1. So in summary, what you do is you multiply this cofactors that you create by the element in the row or column that you are using to create the cofactor. So this equals essentially 1 times 1 minus 0. Then we're going to have minus 1 here times 3 minus 0. Then we're going to have plus 1 times 6 minus 2. And oops, this is a mistake. 0 times minus 1 is 0, not minus 1. So this is actually essentially plus 0. And that is 1 plus 4 equals 5. So in general, for any square matrix, to find the determinant, you multiply any element in a row or column by its cofactor. So the elements we chose then are 1, 0, 1. We chose this row because there was a 0 in it and these were 1s. So this was 1 times its cofactor, 0 times its cofactor, 1 times its cofactor. And that results in the determinant of the matrix.